Today our topic is volume of solids. So our learning target, how can I find volume of prisms, pyramids, cylinders, and cones? Volume, the number of cubic units contained inside a solid. So whenever you find volume, your units are going to be cubed. So it'd be like feet cubed or inches cubed or centimeters cubed. That's how you label your volume. A couple postulates. Volume of a cube postulate. The volume of a cube, because cubes have all congruent sides, is the cube of the length of its side. So side times side times side, so it'd be side cubed. Postulate 28, volume congruence postulate. If two polyhedra are congruent, then they have the same volume. So if they're the same polyhedra, then they have the same volume. Postulate 29, volume addition postulate. If the volume of a solid is the sum of the volume of all its non-overlapping parts. All right, so if we had another cube drawn on top of here, then we could take the volume of the two cubes and add them together. Volume of a prism. So the volume of a prism is area of the base times the height. So B is the area of the base, H is the height. Volume of the cylinder is the same thing, but we know that the area of the base is going to be pi r squared because the base is going to be a circle. So the volume of a cylinder is pretty simple. Volume of a prism can get a little complicated depending on how complicated the area of the base is. So find the volume of the solid. Write trapezoidal prism. So trapezoid. To find the area of a trapezoid, remember our formula is 1/2 times the height times the sum of the two bases. We are going to need that formula because our volume is the area of the base, so we're going to use that formula, times the height of the prism. So the height of the prism is this 5 centimeters. So that's going to be our H. So we know the volume is equal to the area of the base times 5. Now we just need to find the area of the base using our trapezoid formula. So area equals 1/2 times H. So the height of the trapezoid right here is this 3 centimeters times the sum of the bases. Well, one base is 14 centimeters. And the other base, if we look here, is 6, because this would also be 6 right there. So area equals 1/2 times 3 times the sum of 14 and 6, which is going to be 30. So the area of our base is equal to 30. Plug that in to our volume equation. We get 30 times 5. Volume is equal to 150 centimeters cubed. Part B, we want to find the area of a right cylinder. So not the area, the volume, my apologies. Our volume formula is the area of the base times the height, so pi r squared times height. Radius is 9, height is 6. Plug in the numbers, like I said, a lot easier. Put that in your calculator to solve, and we get 1,526.81 feet cubed. Next example, we have Cavalier's principle. I think I'm saying that right. If two solids have the same height and the same cross-sectional area at every level, they have the same volume. What this is really just saying is that we can apply our theorem for volume of a cylinder, even if it's not a right cylinder, to oblique cylinders, because they still have that area of the circle at each cross-section. So the area of the circle there and the area of the circle here at this cross-section would be the same thing. So we can still find the volume by doing the area of the base, so pi r squared, times the height, where our radius is 4 and our height is 7. So plug it in, volume equals pi times 4 squared times 7. We get that the volume is 351.86 centimeters cubed. Next piece is volume of a pyramid and volume of a cone. Very similar to our prism and cylinder ones, except for now there's a 1/3 on the top because it's 1/3 of the volume because they come together at this point at the top, so it takes away some of that volume. So B is still the area of the base and H is still the height. We're just going to take 1/3 of that. So then the volume of a cone is 1/3 times pi r squared H. So in example 3, we want to find the volume of the solid, round our answers to 2 decimal places if necessary. Hexagonal pyramid. So volume formula, 1/3 times the area of the base times the height. To find the area of the base, when it's a regular hexagon, we have to go back to what we did in 11.6, where the area of our base is 1/2 times the apothem times the number of sides times the side length. We need to find those 3 things. We need the apothem, number of sides, side length. If we look at our diagram, we know the side length is 4. We know it's a hexagonal pyramid, which means the number of sides is 6. We just need to solve for that apothem. So remember, we make that little triangle. Make that triangle. Draw in the apothem, the height. The side length is 4, so this side is going to be 2, and this side is going to be 2. We can find that central angle by doing 360 divided by the number of sides. So 360 divided by 6 is equal to 60. So this whole angle is 60. So if we just want that one piece, this piece would be half of 60, which is 30. Use a trig ratio to solve for A. Trig ratio, we would want to use tangent because we have the opposite side and the adjacent side. So the tangent of our 30-degree angle is equal to our opposite side over our apothem. Solve for A, we get A equals 2 over the tangent of 30. So then A equals 3.46. So if we go back up here, A equals 3.46. Now we can find the area of our base by doing 1/2 times 3.46 times 6 times 4. Just plugging in all the pieces into our equation. We find that the area of the base is 41.52. Now that we have the area of our base, we can find our volume by doing 1/3 times the area of our base, which is 41.52, times the height of our pyramid, which is 11. And we get that the volume is equal to 152.24 yards cubed. All right, next example, the right cone, which is much easier. Volume equals 1/3 times pi r squared times the height. If we look, we know our radius, which is 5. However, we do not know the height of our cone. We do know the slanted height, but we don't know the actual height here that I'm shading in blue. But we do know that this is a right triangle with 5, 8. We can solve for the height using our Pythagorean Theorem. So the height would equal the square root of 8 squared minus 5 squared, which would leave our height as equal to the square root of 39. So we can put our height is the square root of 39, plug that into our calculator to solve for the volume, and we get 163.49 meters squared, or cubed, my apologies. All right, one last example for you guys. Last example for you guys, we want to find the volume of the solid shown. So we have 2 pieces. We have a square pyramid, and then we have a cube. So we need to find the volume of both and then add them together. So if we start with the volume of the cube, volume of a cube or a prism is the volume, is the area of the base times the height. So area of the base would be 6 times 6, and then times our height, which is also 6. Do 6 times 6 times 6, and we get 216 meters cubed. Then if we do the volume of the square pyramid, our formula for the volume of the pyramid is 1/3 area of the base times the height. So 1/3 area of the base, it's got the same base as the cube, so that square 6 by 6. So it's going to be 6 times 6 times the height. It also has a height of 6. So our volume is going to be 1/3 times 6 times 6 times 6, which gives us 72 meters cubed. So the volume of the entire solid is going to be 216 meters cubed plus 72 meters cubed, which gives us a volume of 288 meters cubed. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.